purpose of this video is to show you how to graph quadratic inequalities. Now, this process is exactly like what we did with graphing linear inequalities, except the boundaries that we drew in that chapter were straight lines, and the boundaries we're going to draw here are parabolas. So essentially what we're going to do is figure out what the boundary is going to look like, figure out if it's dotted or solid, and then shade. So this is a parabola that's in vertex form, and if you look at the inequality here, that is less than, not less than or equal to, so this is going to be a dotted boundary. So what I'm going to do is plot this boundary as if it were an equation, and my vertex, because this is in vertex form, is 3, 4. So I'm going to pick numbers around 3 to plug in for x and see what I get back for y. So when I plug in 1, I get negative 2 squared, which is 4, plus 4, which is 8. When I plug in 2, I get negative 1 squared, which is 1, plus 4, which is 5. When I plug in 4, I get 1 squared plus 4. And when I plug in 5, I get 2 squared plus 4. So I'm going to take those points and plot them. Now, this is not going to be the prettiest graph. It doesn't have to be right now because I'm just trying to give you an idea of what this is going to look like. So let's see, 1, 8 is about right here. 2, 5 is about right here. 3, 4 is right here. 4, 5 is here. And 5, 8 is here. So that's going to be the shape of my boundary. So in order to draw the boundary, it's going to be dotted. So I'm going to draw a dotted parabola that connects those points. And again, if this had been less than or equal to, that would have been solid. So now I've got my boundary drawn. I know it's dotted. So all I have to figure out is which way to shade. And so the way to do that is with a test point. And remember, a test point is any point that's not on the boundary. So I would always choose 0, 0 if it's not on the boundary. And to test it, you plug it in for x and y and see if the corresponding statement is true. Well, this says that 0 is less than 9 plus 4, which is 13. That is indeed true. So the area where that point is would be shaded. If it weren't true, the other area would be shaded. Now, before, we had a straight line. The two regions were above and below the line. Here we have inside and outside the parabola. And the origin was outside the parabola, and when I plugged it in, it worked. So we shade outside the parabola. Okay, so when I look at something that's in standard form like this, the process is exactly the same. The only difference is we have to get the vertex to start with. And there's a couple of ways of doing that. You could complete the square if you wanted to, or you can get the negative b over 2a thing. I think I'm going to do that. Use the negative b over 2a. So my b is negative 4, so it's going to be a positive 4 over 2 times a, which is 2. So that comes out to be 1. So again, I make my t-chart with 1 at the middle, pick numbers around 1. When I plug in negative 1, I get 2 plus 4 plus 3, so that's 9. When I plug in 0, I get 3. When I plug in 1, I get 2 minus 4 plus 3, which is 1. When I plug in 2, I also get 3. When I plug in 3, I get 9. Now, again, this is greater than or equal to. So when I draw this, this is going to be a solid boundary, not a dotted boundary. So when I plug these points, here's negative 1, 9, 0, 3 is about right here, 1, 1 is about right here, 2, 3, and 3, 9. So I'm going to connect these with a solid parabola. No, not the greatest parabola, but that's okay. And then I'm going to do my test point. Now, my test point here, promise that says test point, is 0, 0 again, because it's not on the boundary. When I plug that in, I get 0 is greater than or equal to 3. And clearly 0 is not greater than or equal to 3. So that is not true. So I don't shade where the origin is. I shade the other region, which would be inside the parabola. So that's how you graph quadratic inequalities.